What is old math world? Here we go. We're going to look at some exponential growth problems. Now we're going to use E in the natural logarithm. So let's first, we've got a problem here. Suppose that $10,000 is placed into a bank account that pays 5% annual interest. Part A, interest compounded continuously. How much will be in the account after 10 years? A, continuous interest is going to be P of T equals P naught E to the RT. Okay? So that's going to give me P of T equals P naught. Will be my initial amount, 10,000 bucks, times E to the R, right there, 0.05 T. And we are looking for 10 years, P of 10. P of 10 is going to be approximately equal to, let's plug it into the calculator. So it's going to be 10,000, 1, 2, 3, times E raised to the 0.05, and we're looking for P of 10, so T is going to be 10 times 10. Okay, so that's going to give us about $16,487.21. $16,487. $16,487.21. Let me make sure again that I wrote that. 16,487.21. Okay? So that is with continuous interest. Now let's do part B if we compound 4 times per year. So part B, we're going to have the formula P of T equals P naught times 1 plus R over N raised to the NT. Okay? And for us, P of T equals 10,000. That's my P naught. Times 1 plus R, 5%, 0.05 over N. For N is going to be the number of compounding periods per year. So that's going to be 4 raised to the 4t. So we're going to get that P of 10. It's going to be about equal to, and let's get the calculator and plug it in. So 10,000, 1, 2, 3, times 1 plus 0.05 divided by 4. Alright, 1 plus 10,000 times 1 plus 0.0 divided by 4, all raised to the 4 times, and we're looking at P of 10, so 4t, 4 times 10. 16,436.19. 16,436.19. 16,436.19. So that's when compounded 4 times per year. So that'd be compounded quarterly. And here was compounded continuously. And you know, when I first started doing problems like this, I would have thought there would have been a bigger difference than that. But here, after 10 years, the difference is only about 50 bucks in these two accounts. Let's look at another problem here. Suppose a colony of bacteria has a continuous growth rate of 10% per hour. By what percent will the colony have grown after 5 hours? So continuous growth rate is telling me that I'm looking at P of T equals the initial condition, P naught times E to the RT. Okay, and now P of T equals continuous growth rate by what percent? So we don't have it, they don't give us the initial condition, but they give us the percentage, e to the 0.1 t. That's going to be my 10% per hour. Well, what percent will the colony have grown after 5 hours? So this we don't need to know what the initial condition is if we know how it's growing here. So let me just plug it in and show you how this is going to work. P of 5 equals P naught times e to the 0.1 times 5. Okay? And let's get what that e to the 0.1 times 5 is. So I'm going to clear all this out. So e raised to the 0.1 times 5 is going to equal 1.649. Let's go with 4 decimal. 1.6487. 1.6487. P of 5 equals P naught times 1.6487. Okay, and so that's going to be what's about equal to. We rounded, so that equals P times 1 plus 0.6487. So that means that we increased by about 65%. So therefore there is an increase of about 65%. Remember, to increase something by 65%, oops, I should have, to increase any number, P naught, whatever, to increase it by 65%, the one that gives you your P naught back, and then plus 0.65 will give you your additional 65%. We see that's about what we got here, so it's an increase of about 65%. Check my time. I think we got time for one more. Okay. What annual interest rate is needed so that money will double in 7 years when compounded continuously? So we're compounding continuously. Let's go to green, talking about money. P of t equals P naught times e to the RT. Okay, what annual interest rate is needed so that money will double in 7 years? So we need it to double in 7 years. If our initial amount is P naught, when it doubles we have 2 times P naught equals P naught e to the and we know we're in 7 years, so it's going to be 7, t is going to be 7 times r. Okay, divide out by the P naughts. Okay, they cancel each other. When we get 2 equals e to the 7r. Okay, and now we're going to take the natural log of both sides. ln of 2 equals the ln of e to the 7r. That's going to give me that 7r equals the ln of 2, because the natural log of e to the 7r, it says what do I raise, so this is base e, so what do I raise e to get e to the 7r? Well, surely we raise it to 7r. So r is going to equal the ln of 2 over 7. So r is going to be approximately equal to the ln of 2 over 7. So where am I? ln of 2 divided by 7. So about 0.099. So that's 0.99. So R is about 10%. So that is what. So we would need an interest rate of about 10% to double in 7 years when compounded continuously. Okay, and that's going to do it for this video. Stay tuned for the next one. We'll do a couple more of these problems.